be what? A fraction. We call this is a rational exponent rule. We call this is a what? Rational exponent what? Rule. The exponent can be a fraction. Okay. What is a rational exponent rule, Mr. Good? It's very simple. The rational exponent rule. Let's explain this way. Rational. This is a rational what's the exponent rule, okay? This is a rational exponent rule. Then when we just talk about the rational exponent rule is whereby you're just going to look at what's the radical sign, okay? Then for example, if I'm just having what's m over n, okay? M over m. A raised to m over m. This is same as what is same as n square root of a raised to m. We call this is a rational exponent rule, okay? Then for example, again, Mr. Good, if we have 3 raised to 2 raised to 4, this is same as 2 raised to 4 over 3. Therefore, the number that is a denominator on the fraction is going to be what in a radical sign, okay? Then as you see that we have 3, this 3 that's a cube root is going to be what is the denominator. The exponent is become what a numerator. Therefore, we call this is a rational exponent what rule, okay? Therefore, when you're just solving the rational exponent rule, it's very simple, grade 11. It's very simple. What is important to take note is that the number, the variable that is at the middle, x raised to 1 over 4, we say let is equals to k. Do you see that? The first thing that you need to do, that is the rule. Let k equals to x raised to 1 over 4. Do you see that? That is a k method. We call it is a k what? K method. Okay? Therefore, let k is equals to 1 over 4. Or let's say like this. Let's say like this is the same thing. Let's say like this. Let's x raised to 1 over 4 equals what? Equals to k. Do you see that? Then this number, this variable with the exponent that is always at the middle, we say that is equals to k, is a k what method, okay? We call it is a k method. When do you use a k method? We use a k method only if on the right hand side, only if on the right hand side is equals to what is 0. Grade 11 is very important to take note. You can't just use a k method if we have a number on the right hand side. Please take note of this. These are on the right hand side must have what? 0. It's very important. As you see here, we have 0. Then you can able now to use what? A k what method. Okay. Then after that, we substitute. Let's substitute. Okay. Let's substitute. What is going to be happen here, Mr. Good? This is going to be equals to now k squared minus 3 times k minus 10 equals to 0. How now this one is k squared, Mr. Good? Because 1 over 2 is less than 1 over 4. Some of you, they are just saying that 1 over 2 is less than 1 over 4. No, 1 over 2 is what is less, 1 over 4 is less than 1 over 1 over 2 is greater than 1 over 2. Okay, it's very important to take note. The bigger the denominator, the smaller the fraction. The smaller the denominator, the bigger the fraction. Only if we have 1 on the numerators, okay? We normally say that in grade 4, okay? We say that if you have 1 on the numerators on the fraction, the bigger the denominator on the fraction, that means the smaller the fraction. The smaller the denominator on the fraction, that means the bigger what? The fraction. Okay, you understand? That is the rule that we use in grade 4, okay? All right, okay, let's go. Then, let me explain here what's happening, why you get now case of this, okay? All right, look, we said that x1 over 4 is equals to k, all right? Then if I'm just multiplying another x 1 over 4, do you see that? 1 over 4. The rule says, what the rule says, if you're multiplying the same base, we're going to take one base and add what? The exponent. That is the rule of exponents. Do you see that? Have the same bases, I'm going to take one base and add the exponent. When I'm just adding the exponent, what I'm going to get? I'm going to get what? 1 plus 1 is equals to what? 2 over 4. Then 2 over 4 is same as what? 2 over 4 is same as 1 over 2. Huh? That means that x1 over 4 times x1 over 4 is same as x raised to 1 over 2. But we said that is k and we said that is k. Therefore now that means x raised to 1 over 2 equals what? K squared. K times k is equals to k squared. Therefore, that's why we say that now x raised to 1 over 2 equals what? K. All right? Let me repeat again. Okay? Okay. We are just pretending that we're going to take this one, you multiply 2 times. We say that 1 over 4 times 1 over 4. We just solve it. X times 1 over 4 is times 1 x raised to 1 over 4. Okay? Then what we're going to do here, we take one base. If you multiply the same bases, two same bases, you take one base and add the exponent. Then what the exponent is 1 over 4. Then you add the exponent. 1 over 4 plus 1 over 4 is same as what? 2 over 4, which is raised to what? X raised to 2 over 4. 2 over 4 is same as 1 over 2. How? Then we say that x raised to 1 over 4 times x raised to 1 over 4, x raised to 1 over 4 is equal to k. That means k times k. K times k equals to k squared. Therefore, that's why we draw a conclusion now. X raised to 1 over 2 is same as k squared. All right? I think you get it that, okay? We always use that rule. We always use this rule. It's going to help you a lot, all right? Okay. Then now we have a quadratic equation, okay? We need to solve the value of what? The value of k first, okay? Let's solve the value of k. Then we're going to say that we use a quadratic formula or u factorials, okay? Then we look the factors of what? Of 10. That's going to minus and get what? 3, okay? You just check the factors of 10. That's going to minus them, then you get what? 3, okay? Therefore, what those factors with 5 times 2 equals to 10. Then if I'm just saying that 5 minus 2, I'm going to get what? 3. That means I'm going to open what? 2 brackets, okay? It's very simple, okay? But please use the quadratic formula if you don't know how to factorize, okay? Then we have k, and we have k, we have 5, we have 2. Therefore, the sign of a Mickey term is going to the bigger factor, then it's negative. This negative is just telling you that the signs are no longer the same. If you put negative on the bigger factor, therefore the second sign is going to be positive, okay? As you see, the signs are not the same now. Therefore, we draw a conclusion now. K equals what, -2, or k equals what, 5. Okay, but we don't need what the value of k, we need what the value of x. Now then we draw a conclusion. Now x, you come here, x 1/4 is equals to -2, or x raised to 1/4 is equals to what, 5. Instead of writing k now, we're going to write what, 5. Instead of writing k here, we're going to write what, -2, because now we solved that k is equals to -2 and 5. Then we're going to solve now what in the x. Okay, but here you can't solve this one because we have a -2. You can't, because this is not equals to a negative exponent. You cannot change this what, x to be what, negative. Okay, and also you cannot change what this negative base to be what, negative. Therefore that's why it's not. Okay, since the base now it is what, negative. But this one, it is possible to be what they say. How? Let's go, let's check. Then we're going to say that on this side we're going to have x, we have x raised to 1/4 equals to 5. Okay, then how are we going to solve this one? It's very simple. Then if we have this rational exponential rule, we normally say that we do the inverse operation of what, exponent. What's the inverse operation of exponent? We multiply with the inverse operation of exponent. Like we're going to multiply by 4/1, which is gonna be what, 4/1 on this side. Okay, then let's put this one in the bracket. Then the thing that I did on the left hand side, do on the left hand side, I must exactly do on the right hand side. Therefore this one is going to manipulate this one manipulate this one. Then we have x equals to now 1 times, this is the power rule, 4 divided by 1 is same as 4. 4 times 1 is same as what, 5 raised to 4. Okay, 5 raised to 4, you punch your calculator, we're going to get what, 225. I think it's 225. Let me check. I have the laws of exponent. Yes, it's 225. Okay, then x is equal to 225. Okay, then it's very important to take notes the inverse operation of exponent. Okay, then let me teach you. If we have x raised to 2/3 equals what, 2, how we're going to solve this one is very simple. You do what, the inverse operation of what, of exponent. We multiply the inverse of this fraction. What is the inverse? The inverse is where you take a denominator is becoming the numerator, numerator is becoming what, a denominator. Okay, like we're going to multiply 3/2. These 3's become a numerator, numerator become what, a denominator. That thing that you do on the left hand side, you do exactly on what, on the right hand side. Therefore on the right hand side we have 2, like this, 3/2. Do you see that? Therefore this one cancel this one, this one cancel this one. Then we left with x equals to 2 raised to 3/2. Do you see that? Then you punch your calculator here. All right, then let me do another one. If we have, it's very important, you forgot this rule in the exam. I don't know why. It's very important to take notes. Then for example again, if we have x raised to 3/5, then is equals to what, is equals to 25, is equals to 25 or 125, like this one. We're just saying that solve for x. It's very simple. What we're going to check, we're going to look at what is the exponent. How the exponent is a rational exponential equation. Then what we're going to do, you do what is the inverse operation of the exponent. Therefore, how we're going to say that we have x raised to 3 over 5. Then we multiply the inverse. This is the inverse. We have 5 over 3. That is equals to 125 times 5 over what? Over 3. Like this one. So you see that? Then after that, you punch or calculate this one, manipulate this one, cancel this one. Then x equals to, then you punch your calculator, you're gonna get what? The answer here. Then you are done. Then you get what? The correct answers. All right. Therefore, that is all about the rational exponent equation. Please, please, please don't forget this rule. We use the K method. After that, it's going to be a quadratic. Then you factorize or use a quadratic formula to solve the value of K. After that, you take the value of K, you substitute here, and that's what x raised to 1 over 4 equals what? K. Then you solve the value of the value of what? Of x by using what? The rational what? The irrational inverse of what? Exponent. The denominator become the numerator become what? A denominator. So that you're just gonna have what? 1 on the left hand side on the exponent. Then after that, you punch your calculator, you get what? The solution. Mr. Good.